Hi, another very important concept in statistics is the z-score. The z-score is also and often called standardized value. Z-scores are also denoted as z-values. Z-score, z-value, they are interchangeable, so they are the same thing. So what is a z-score? Let me show in practice what a z-score is. So here we have one example, which is class size. So we have different classes, 1, 2, 3, 4, and 5, and different number of students in each class. And then in this first class we have 46, in the second one 54, and so on. The mean for all these classes is 44 students. And the standard deviation, if we compute the standard deviation, is 8. So how much this class is deviating in standardized values from the mean? The mean is 44, this class is 46, so it's above the mean. And the deviation above the mean is two students. So this class has 2 more students than the mean of 44. So if we use this formula, we can compute the standardized deviation that this class is from the mean. This is what the z-score represents. It represents the deviation of each observation from the mean, take into account the standard deviation. So this is what it's talking about. Each observation, 46 minus 44 divided by the standard deviation. Okay, so the z-score for this first class is 0.25. It's positive because it's above the mean of 44. So it's higher than 44, so it's a positive deviation. How much? 0.25 of a full 1 unit deviation. Okay, this second class, look at that, 54 students, the mean is 44, so it's 10 more students. This is how many students more this class has in terms of absolute deviation from the mean. But in terms of standardized scores, in terms of standard deviation, how far this class is from the mean. So if we get 10, if we get this deviation of 10, which is this numerator, 54 minus 44 is equal to 10. 10 divided by the standard deviation of 8, we have 1.25 standard deviation above the mean. So it's a positive number, is higher than the mean of 44. In terms of standard deviations, this class is 1.25 standard deviations above the mean. And we also have classes that are below the mean. Let's take a look at this one, 32. So if I get 32 minus the mean of 44, I have negative 12. So negative 12 divided by the standard deviation of 8 gives us minus negative 1.5 z-score, which means this class is, in terms of standardized deviations, is 1.5 standard deviations below the mean because it's negative. Okay, so this slide talks about looking at one example in MindTap. Again, MindTap is good because it has all these illustrations. Let me show you next in MindTap how it works. So here again is our MindTap chapter 3. I'm going to expand chapter 3, and then I have many contents. I'm going to look at this exploring statistics, converting to z-scores. So let's take a look and see another way of looking at that, okay? So what we have in this first line is the raw data, and I think that's the same data we have on our slides, 5 classes with a mean of 44 students and a standard deviation of 8, okay? So the mean is 44 here, the mean is 44, and the standard deviation is 8 because we computed. And let's assume we compute it in Excel, there is a calculator, it doesn't matter, okay? So this line is the absolute number of students in each class, and the line below is the standard deviation, okay? Is the standardized values for the class size. So the mean becomes a standardized score or z-score or a z-value of 0. Why? Because it's at the center of the distribution, and if I subtract 44 minus the mean here, 44 minus the mean, 44 minus the mean of 44, I have 0, 0 divided by 8 is 0. So always the mean of any variable is equal to a z-score of 0, because the z-score of 0 tells me that I am at the center of the distribution of values. Okay, so again, you see, we have a class of 32 students, a class of 42, two classes of 46, and one class of 54. Let's start looking at the class that has, you see, I'm moving this this bar and going down in like values of 0.25 standard deviations, or so this is like for a class of 32, how much I deviated from the mean. I deviated 1.5 negative, which means below the mean, because this 32 is way below the mean. So in the opposite side, if I go up for a class of 54 students, how much I deviated from the mean. The mean is our z value of 0, so I go up until 1.25. Okay, so this is what z-scores are doing, are standardizing the deviations from the mean using each observation, the mean, and the standard deviation. Okay, so let me show you in Excel how you do that. So here's the same data set, the classes and the difference from the mean. That's something we have to compute here. I put a formula so we can compute. Let's compute first the mean for these classes. Okay, so this is equal to the average of these classes, which is 44. We know that. Let's compute the standard deviation, stdv.s, open parentheses, and then I select this raw data, close parentheses. That's the same numbers we have on slides and on Mind tab. Now I can use Excel and the formula in Excel to come up with the z-scores for each one of these observations. This column is just to illustrate how each one of these classes is deviating from the mean of 44. So difference from the mean, only 2 units, 10 units, and so on. Okay, so now let's use all these pieces of information and this piece of information to come up with the z-scores for each observation, or each class in this case. So I type equal standardize, okay, and this shows the formula in Excel. Returns a normalized value from a distribution characterized by a mean and standard deviation. This is what we're doing. I open parentheses, and then I need 3 pieces of information. The first piece of information is right here, is the x. The x is the value I want to standardize. The value I want to standardize is this, and then the next information I have to input is a comma, and then Excel turns into bold this piece of information, which is the mean. Excel is blinking here, it's telling you what is the mean. So you have to select the mean or type the mean. You can type the mean, and then I type comma to tell Excel that's it, that's the mean. And now I have to type or select the standard deviation. I can select here, or I can type. Let me type to show you how you can do. You can type 8 instead of selecting the cell. Okay, so this is z-score of 0.25. Okay, now I can scroll down this formula to all other cells. If I lock this cell C9, I have to lock this cell, because if I scroll down, let me show you what happens if I don't lock and I scroll down. I have problems, because now this cell in the middle, the mean, is getting nothing here because it's moving the cell down. So let me go back and let me lock. How I lock this cell C9? I type F4 in my keyboard. Okay, for Mac users, you have to type the key Fn and F4. Okay. So when I do that, Excel places 2 $signs here, and that means that this cell is locked, and I can move down the formula and that cell will be the same. Okay, so let me take a look at this last one. If I click here, the A7 is the value I want to standardize, C9 is the mean, and 8 is the standard deviation that I typed. I could select the cell, but I typed just to show you that you can do either way, typing or selecting the cell. Okay, so this is how you compute the z-scores. I think you understand what z-scores are. Here's some more additional explanation, like z-score is a measure of the relative location of each observation in a data set. So how far each one of, for example, these classes are from the mean. And a data value less than the sample mean will have a z-value, a z-score less than 0. A data value or an observation, a class in our example, greater than the sample mean will have a z-score greater than 0. And a data value that is equal to the sample mean will have a z-score of 0. Okay, so z-score is very important for our entire class, the entire semester, or the entire, in this case, month will be together in this class. We're gonna be talking about z-scores. Okay, so z-scores can be used to standardize age in class, and you can see them in a histogram, like in a distribution, and then all this information come together when we're talking about z-scores.